I've been up here telling everyone what New Relic is and how it's a platform. It's a platform! We call it the platform sandwich. It has buns.
Oh, I love sandwiches.
No, everyone loves a good sandwich, especially when you don't make it yourself. Sandwich is a subscription. SAS. It's got some lettuce in the middle. It's delicious.
Bacon.
Let's go make a sandwich, dude. One of the things that's really cool to me about New Relic is that it collects data from lots and lots of stuff. We actually have a lot of like IoT customers now. They're building out like big machine learning environments, and then there's like the GE Predix platform is a huge New Relic sort of example. I think you can like look at their success case. Our marketing team did with them. They instrument like the IoT portions of the Predix platform, and those are like big manufacturing systems. They're instrumented so that we can, see? Now I'm gonna have to start over.
So that's the problem with these Reddits.
Always late. Can we start over with the sandwich? Alright, it's okay, we can do the sandwich again. You guys did? Alright, cool. Is anyone else coming?
Not sure.
Okay, cool. We won't start again. Alright, sorry everyone. So yesterday I was saying I pretty much just presented like super basic stuff, so not super interesting, so today it's gonna get weird. I was talking about how New Relic is a platform. It's a platform sandwich. Stick some buns on there. Maybe some lettuce in the middle. It's tasty. One of the cool things about New Relic for me is that we collect all these data points from all these different devices, and I was just talking to them about how GE is one of like they're making a big IoT push. Actually, the company's going into shitter, but the Predix division is heavily invested in New Relic. They instrument all the IoT backends and sensors on the infrastructure agents. It's like a lot of volumes of data. So we architected New Relic scalably. You guys are under NDA, so I can share this. That's our architecture diagram. So from the agents through, those are actually on the actual endpoints where we gather metrics and traces and events and things like that. Through the firewall, we have data routers, which are like our edge of the network. We call them the spines. I'll show you some of the traffic actually in the next slide. But we come through those spines. We heavily utilize Kafka. Every different agent, we actually have a really beastly Kafka instrumentation that replicates different topics across different data centers for fault tolerance. So if we lose an entire data center, actually we can lose up to 2 data centers, we'll still keep ingesting data, it's fine. It's pretty cool.
How much data settles in?
We have 3 availability zones in different colo facilities run by the same company in Chicago. And we're building a European data center right now. I think it's going to be in Germany because the Germans are in our country, nowhere else. Even if it's just telemetry metrics. The growth strategy for the company is to like expand into new markets. Weird, right? This is the network engineering dashboard that's built in New Relic Insights. It uses custom events. And it actually is, you know what S-flow data is? Anybody familiar with network engineering?
Yeah, S-flow.
Me, Steven. Only me and Steven are networking geeks. Well, if you got a CompTIA Cisco 8500, you know what S-flow is. It's basically just metrics about the packets that pass through a router. And so you can see the 4 spine routers there, pumping about 60 gigabits per second of data each on the list. Yeah, and that all goes back into the back end through sharded MySQL databases. There we actually use Kona, the original high performance MySQL variants, and we've actually switched overnight. We never knew to Cassandra. We never even saw it. We're not doing mobile here.
So you stopped using MySQL, you switched to Cassandra then?
Mostly Cassandra now.
Why did you
switch?
It's faster. pin it in memory is faster. A lot of RAM and SSD in the back end of your health. NRDB is all SSD memory databases as well. That's how it's so fast.
It's faster, it's more expensive. It's more expensive. What?
Less expensive.
Depends.
We're racking our own hardware in there when it's on bare metal.
Yeah, okay.
You have your own laptop? You don't run on AWS?
No, they're the one that doesn't.
We're hypercurrency.
Oh.
We're like, the cloud is the future and we want to monitor cloud stuff. Really, we do leverage AWS. About 30% of our infrastructure is on AWS. So, I think that's pretty cool. So, what do you even care about that for? So, one of the things that we're doing in the future, this talk is about the future of Relic, is applying the machine learning algorithms to the data we collect. And we have all this data that I showed you, right? 300 gigabits per second. One of the places we already shipped a feature where we're using applied intelligence is in air analytics. I think I actually just completely skipped over this the other day. The air profiles tab there, it's like new, I'm new, click new. See how you can facet and filter the errors, right? You can filter, pick out a class, and then say, is that exception occurring on one host or many hosts? What if you could just have something do that, all that for you? That would be super nice. You wouldn't have to click anything. So, air profiles just do this all automatically. It runs every facet in NRDB for all the errors for you. One might argue this is not really AI, it's just like a fancy report, but it still saves a shit ton of time. I asked this feature a million times because what I do in customer accounts is I go mine the data, and I help them find valuable information, and I, show it to them. Now I just click a button and it does it for me. It's pretty nice. So what's this telling us? It's telling us we have a lot of inbox out of balance exceptions. Password expires, most of these are in post. That's cool. And then if it's actually a little bit more powerful than that, if you filter, it will filter. So of the index out of bounds errors, they all appear on oops.jsp. They're all invalid password errors, it looks like, that for passwords that are too long. So that's the issue. And we didn't have to facet it 2, 3, 4 times to figure that out.
What kind of errors will we see? Unhandled errors or?
This is the error analytics page where we track outer exceptions and any unhandled exceptions. So 400, 500 errors and unhandled exceptions. You can also send errors here in the notice area API, which is part of the instrumentation piece.
So you get the stack trace too when you see the error?
Yeah, we capture all the errors.
And how do you build the stack trace when it comes to node?
Sometimes we don't. Yeah. There's like outer exceptions we miss the stack trace a lot of times. So the other part of this is the baselines, which I showed you guys yesterday. So we can take any of the different data streams coming on to the Relic, and they can be baseline. So things like application metrics for throughput have certain seasonality trends in them that are intrinsic in the data, and we have algorithms to watch those. And let's go web UI. This app, system traffic pattern. You can baseline anything pretty much, even custom metrics now. So each agent emits, depending on how big the app is, I don't know, 1,000, 3,000 metrics for each component. It automatically instruments, and you can even search through those custom metrics and baseline those. Let's see, you can play that, set the sensitivity. Once you save this, the algorithms will keep trying to use feature fast forward to predict what a good algorithm applies it. So there's like day over day, week over week, day-to-day, Monday comparison. There's 7 different algorithms that it runs, and it's continually testing to see if the shape of the data changes and if it should go to a different algorithm. So that's compare with like, I'll screw it, Datadog, who does this. This calls it AI, but you have to manually select the algorithm you want to use in the seasonality chart. And other competitors also the same thing. We just kind of like take all the overhead off of it. So that's our version of that. And then the vision of the future is this. I think this will come out this year. Don't hold me to it, but this is Radar. Radar is essentially like having a robot that looks at all the data that you collect in your account and is looking for patterns and trends and degradations in, say, your application response times when you're not really looking at the data yourself. So maybe you wouldn't be alerted to these issues. They're maybe not critical failures, right? Where like my app is down, my users are unhappy. That's not a use case for Radar. This is more along the lines of someone did a deployment, you should know about it. Or I've got an N+1 query anti-pattern in this handler, and you can drill into it here. So just kind of trying to save you time. Answers.
This is not available for us yet, right?
Not available for anyone yet.
Oh.
It's like in beta. They're deciding what features to ship it, basically. So client controller get plans is a right. Oh, handler. Sorry. Alright, well, oh, there it is. Trace. Should see a. I actually see it. Well, this is the old one. That was from yesterday, that's why. So, I was looking at the wrong data, but essentially, this is the notice that we had a very bad word pattern. So that's the idea of what we're going with New Relic in applying intelligence to the data we have. I'm going to end with the roadmap and like the next few things we're doing, and then we're going to do my agent right now. So switching gears.
Okay.
So I think you guys are here because you want to learn more about custom instrumentation stuff, right? What we're going to do next. So customizing the agent is kind of like tricking out your car. There's a bunch of different ways I talked through yesterday. I think I tried to demo most of them, but I think it's helpful to just review. So you know the transactions list. You can modify those names to be custom, and you can set them dynamically. You can add additional depth to the transactions when we trace a transaction. We call these tracers. Custom attributes, so adding additional context to a transaction when we track it. Say user ID was one of our prime use cases. I think during the browser session this morning, there's a query parameter that they would want to capture from when they're like fetching a project folder. Something like in the URL bar, we don't capture it by default because it could potentially contain like authentication headers, something sensitive. But you can opt in to send those to us. You need to explicitly opt in to send those to us via the API. This is by design. Then custom events, so you have like a workflow in workflow service that you wanted to beam a custom event out for, kind of like the command processor, the Shanghai team instrumented business command processor, and upload command processor. And then last one's custom metrics. This exists. Mostly doesn't make sense to use it anymore. We're going to skip over it. So what do you get custom transaction naming? Pretty simple, but on the left, we actually have like what default transactions would have been, all the entry points based on the framework that we detected. And then on the right, what we could rename those to. There's a bunch of different APIs in the different language agents, but I pulled out at the end of this, the specific API calls for each Node and Python. Those are the main languages you guys are developing in, right?
No, that's Python. Yeah.
Mostly Node and Python. I think some Ruby, but
Yeah, Node and Python less.
Ruby is gonna die.
Node is the main.
Ruby's gonna die.
Yeah.
No, not today, but
Eventually.
Oh, you're saying in general.
No, it's well, not from our side. Yeah.
it's on our road.
Ruby is not gonna die.
Our Ruby service is going to die someday.
Got it. Do you think Ruby generally will die? Have you guys seen Phoenix, the Elixir Erlang Resurrection? Pretty sweet. Sorry for that.
Yeah, it's really hard to find a developer who are expertise in this section. Ruby. Yeah.
Really?
It's relevant.
Oh, okay. Okay, makes sense. Bay Area, everyone loves Ruby. Although, I would say, like, most of the applications I see that are Ruby are, like, monolithic and they're very resource intensive.
Yeah.
And the newer languages are just much lighter. Like, if you're gonna put something on cloud, you don't want it to be Ruby. It's expensive. Okay, so we're getting sidetracked. Here's an example of custom transaction naming. This is in Java. Java guy, sorry. But I think the same concept applies. So in Java, the API call is new relic set transaction name, and you can tell the agent if it's a front end transaction or back end.
That's what you do on the XML file?
No, no. Use the APIs in your code.
It's what you can do in
So that's the
config.
method, public list hotel, find hotels. And the object input is search criteria. And then inside of that method, because New Relic already instrumented that automatically, we're just renaming it. So it's just a cosmetic. Make sense? You can do this if you like have really ugly custom or automatic transaction names.
Will that also go back and change the ones that are already in the system? Or will that only just for going forward from that point on?
Only going forward from that point.
Is there any, I see the percentages are different. Is there any difference other than cosmetic change? Like obligations?
Alerts automatically adjust to this.
No, probably not. Then I don't actually know.
So if I build a dashboard I build on an
Well,
RTL.
it depends on how you build the dashboard.
No.
It depends on how you set up the alert too, I guess.
How do you identify a transaction? Just by this annotation? It has nothing to do with
No, you would see in our UI, this find hotels, or it'd be like /hotels get or something.
Yeah.
And maybe that's not like a total, it's not a very accurate representation of the actual transaction if you understand what it does, right? Because it's going to grab the method name. So like this one actually in this example would be find hotels. And then we just made it pretty looking, basically. So if your code is well documented, you have good consistent naming conventions, like you shouldn't need to do this most times. It's an option if you want to do it cosmetically. This is an example of blue dot syndrome. You may have seen this in different applications. Probably not so much in Node and Python. This probably doesn't really happen, but it's worth going over. So we can add custom tracers. Tracers affect the transaction traces for the slowest transactions, which we save the call graph of them. And what you might see on the left in the transaction traces is this little application code in whatever, in this method. And that means that the agent will trace maybe 1 or 2 or 3 levels into the code. At a certain point, the tracer stops following code because we're just burning overhead to trace we don't know what. If we want to like trace through a recursive pattern or something, we could potentially cause a very high overhead from doing that tracing activity. So we stop because it's safer to stop and leave it fuzzy versus forcing the application to take a very detailed trace. So our sort of philosophy is a safe instrumentation by default. If you look on the right, we added an additional tracer, and it revealed that there's actually a booking, JPA booking service method. This is a demo app where it's method slowed this down that's underneath that application code. We exposed it. Node can do API-based declaration for this sort of thing. We're adding timers to get traced, and Python, same thing. Python's all API driven. This says XML because it's Java. There's no XML distribution for this, for the Python distribution. So here's the stuff that you need to know for Node. You like the sideways Node thing? I thought it was fun. You want to instrument specific modules or data stores. There's actually helper functions, we call them shims for that. You basically pass a module in, and then we instrument. If you want to instrument, like we do express out of the box, but if we have one, we don't do out of the box. We're going to pass it to the web framework. Do that. More commonly, you probably do something like start web or start background transaction. So those have a start and a stop decorator. And all that does is basically creates a transaction you want. So if there's some piece of code you want to mark as a key transaction, if you didn't detect it out of the box, go decorate your code, start an end transaction, voila, it will show up in here. And it will just piggyback off the existing agent. It shouldn't cause any additional overhead or anything. Customers tracking some pretty long running background tests and stuff. Last one is get transaction, and then obviously any transaction is universal for background and web transactions. Get transaction is like, I want to know what transaction object I'm in. So as we instrument a transaction, we can return the transaction name back to you if you want to maybe rename the transaction with some additional context. If that makes sense. Custom events is the other type of instrumentation you guys might do, like the command processor. So you pass it the event type, which is the table in Insights, and you can then pass it an array of attributes. You cannot send us more than 254 attributes. 254 attributes in a single event. We need one for timestamp, and the limit is 255 columns. Actually, the real limit you'll probably hit for that is the payload size, but most people don't ever get that close, honestly. Yours is like maybe 10 or 12 columns or something. I don't look at it. Some agents can just accept like a hash map, so you can send a bunch of different events all at once. And, oh yeah, I pulled the stats for the Node agent. When I joined Relic, we had 500,000 downloads per month. We only have almost a quarter million, so still being widely adopted, probably the most heavily penetrated Node agent. We were the first to have that Node agent, I think. Okay, I heard of this. Now there's like specific ones, but yeah, I don't know. Alright, Python. Python's a little different, but same concepts. You can set a transaction name. You can also group it. Don't group it, just skip that. It's really not an issue. the grouping is something that we'll take care of on the back end generally. And priority is important because in languages like Python, you can the agent can decide to drop data that's of lower priority. So if it has to decide between sending like priority 1 transaction and a priority 10 transaction, it would drop 10 before it drops the 1.
When the agent is working,
Yeah, there's some thresholds to like how much data you can submit per minute, basically. That's on our side, like our reward protection. And most of the agents do not even don't really approach that threshold, or they haven't really extended their APIs to offer a priority feature. So you could do priority done for most of your stuff, but it's there, just so you know what it is. Particularly for errors, some customers throw tons of errors and they desire an error priority. So we added the feature for them to be able to prioritize the errors specifically. Then custom parameters. So we want to annotate a transaction, send it to insights with like user ID. It's to add custom parameter and key value there. And docs. These are really good. If you go on the docs site, I can't plug it enough. The support team has actually written a use case driven custom instrumentation guide for all the agents. So let's look at this real quick. Cannot locate the server. Okay. How do I customize that app name? How do I do transaction parameters? So I want to stop timing methods after starting them. So just the specific use cases that I want to use the various APIs for. Because I know that just staring at the APIs can be kind of daunting. So set transaction name, all the stuff I basically reviewed, laid out for you. That's out there for Python as well. And then this last thing is use cases in the wild with sample code. This is the Node agent repository, GitHub, source available, as is Ruby, as is Python. Although we didn't hear the repo on GitHub was don't know why, but someone neurology fan has done that for us, thankfully. And we actually document examples of how to use the APIs in there. So how to instrument background transactions, promises, things like that. There's a little sample code of starting a background transaction and ending it. So if you're ever like scratching your head, how do I actually use this thing? Just put samples out and get it. And what does this look like when we put custom attributes into the app? So this is on the left is a screenshot of a transaction trace. If you add a custom attribute, it goes into the transaction trace. It goes into insights to decorate your transactions, record all the transactions, and now it goes into error analytics too. So you use it once, it goes into recording. This is an example doing it in Java, which Pac-Man part of that. Alright. And then custom events, send any arbitrary event that you want to notice into the Insights platform. Alright, that's pretty much it. This is an example of doing a super complicated stream map one. It's a key value map, record custom event, passing the map in. Alright, do we want to look at, there's a workflow I think that I think she said she had the workflow